Hello, everyone. We're team 983, and my name is Hemraj. This is Henry, Jawad, Nuhash, and Koi. And we basically, our passion, when we were talking, we love skateboards, whether it was in our childhood or somewhere we're growing up, and we want to enhance this experience for other college students who are currently riding as well. So since we're all computer engineering, we decided to have a skateboard with object detection, regenerative braking, and geolocation.
All right, for the object detection, oftentimes we see many riders on campus that are distracted. So to provide enhanced safety environment for them, we decided to use the TF Mini LiDAR sensor, which is a picture on the upper right corner. The TF Mini LiDAR sensor uses the time of flight technology. With the technology, we can measure the distance by calculating the time difference between the emission of the signal and its return to the sensor. And the maximum distance that it can measure is up to 12 meters within the accuracy of 4 to 6 centimeters.
All right, moving on to regenerative braking, there's three main components that go all into it. There's the battery, the VSC controller, and the hub motor. So with the battery, we decided to use a 12S2P battery to increase range, since that was our main focus. And then with the VSC controller, aka better electronic speed controller, we're able to actually get more advanced configurations with regenerative braking, which allows us to actually change any parameters with it, whether or not the electronic or the regenerative braking will be slowing down faster or slower for the user. And for the hub motor, it'll be able to enable this regenerative braking.
So for the remote location feature, we plan to use a GSM module connected to our Raspberry Pi 4, and that'll let us connect to a nearby cell tower, which lets us access to the cell network. And we're going to use that to interface our board with a web UI that will allow us to monitor the location, battery percentage, any temperature of onboard components. And initially, we plan to do this with Bluetooth, but even with Bluetooth 5.0, it would give us a maximum range limit of about 800 feet, and that wouldn't suit the needs of the project. So we decided to go with the GSM module, and Koi will go a little more into the web UI.
So we're creating the web interface to communicate with the Pi because it's easier to testing and prototyping, and it will be used to monitor the geolocation using the Google Map API to show exactly where the skateboard is on the map. And it is also used for the battery percentage and to see how long can we still use it.
And another feature we added in was the reverse polarity current and protection. Just make sure that our battery doesn't overheat, because we're using is it lithium?
Yes. Yeah, we're using lithium-ion battery.
Yeah, lithium-ion battery, and those are prone to overheating or getting the charge overheats from the regenerative braking.
Yes, exactly.
And to prevent that, we have to include the circuit, and it also helps us save battery.
Or at least increase the longevity of the battery that's given to it. All right. And overall, that'll be all. Any questions for us?
Yeah, what's the practical application for this? I can't see this being used in a skate park, for example.
So the main use of this is for college campuses. So for us, the problem that we faced was there was a lot of students that would ride their skateboard on the street, and they would not look for passing people. They'd just look into the distance, and they would not pay attention.
And then
or they would be looking for people, but they would not be looking on the street. So if there's half an inch rock or anything on the street, and they're going on the skateboard, they're definitely gonna fall if the wheel goes over it, right? So this is to help give a comfortable experience to riders.
It's on your performance metrics, so college students can afford roughly a $1,500 skateboard. That's a pretty cool skateboard.
So the cost should be under 1,500.
Okay.
Yeah, so that line.
So what's your lower bound then?
Can we
Our lower bound.
Our lower bound will be most probably around the $400, $500 range.
Yeah.
Yeah.
Okay, well, having said that, have you guys spec'd out what the component price is on that?
Yes.
That's one of the
Yes,
things.
we have.
So if you add that up, is that where you get that 1,500 number?
The 1,500 is
Or is that a
main.
guesstimate?
Yeah, that's just a rough estimate, and also safe numbers are just used just in case we need additional components.
Requires a cellular connection, right? So you require special cell site, self-subscription?
Yes, it will
Like a
require a
phone.
subscription,
So
but
it's
it's up to the
cost.
user.
Just, then you need to add that into your engineering economics of the cost of ownership. If there's a subscription service.
Are you guys gonna develop an app for it? Because you're gonna have all these things that you're controlling with cameras and cell connection. Are you planning on developing an app?
Yes, we're creating a web interface for it, just through testing and prototyping, but we're aiming for an app later on.
So one of the things I'm keying on here, one of the goals themselves are all very high level. You do have some performance metrics, but most of your goals are not expressed in a way that allows you to have objective metrics that you can show that you accomplished at the end of the next semester. Some of them are very easily converted to that. Others, particularly on the safety, I'm very concerned about the way that you're going about safety, because I don't call it a safe skateboard if it decides that I need to stop suddenly because there's an object in my way. And
Yeah, and you don't
that
want it
happens
to stop.
anyway if I try to do a skateboard, but that's another point. For someone who's going along at a good clip, and some skateboarders do, and all of a sudden the skateboard decides that it's time to stop, that's gonna be really bad for the user. It might be great for the people around them that don't get run into,
Yeah, of course.
but it's terrible for the rider. So there needs to be some kind of metric in there as to what the maximum deceleration allowed would be, and you have to take some data to figure out what that looks like.
Yes, of course. And most of our testing phase will actually be next semester.
I understand that, I'm just saying, you've got to work it into your goals and your
Yes.
objectives and know what you're going to be measuring so that you know when you're finished and you know you have a product that won't really.
That won't like jerk and like
injure
make someone else
your
fall.
user
Yeah, of course.
who spent $1,500 on the skateboard. They're really not going to be happy about being injured by that.
Let's thank.